Hello dear students, welcome to my channel. So let us continue with the chapter on circles from question number 16 onwards. Okay, so the first question, that is 16, says ABCD is a cyclic quadrilateral in which DAC is 27 degree, DBA is 50 degree and ADB is 33 degree, and all of them have been already marked in your diagrams. Calculate DBC, DCB and CAB. Okay, so let's see the first one, that is DBC. So DBC means we have to calculate this angle. All right, now in order to calculate this, we can see that there are many segments being formed, right? And one of the segment is this one, right? So DC is forming one of the segment and DC is making two angles. One is this one, that is DAC, and another is DBC, and we know that angle in the same segment will always be equal. That means this angle and this angle, that is DCB, has to be equal to each other. All right, so that's why we have number one, that is angle DBC equals to DAC, and this will be equals to 27 degree because they are angles in the same segment. Okay, so next is DCB, that is this one, right? So DCB is this full angle. Now we need to calculate this, and in order to calculate this, let us make use of something called cyclic quadrilateral, because we see that A, B, C and D, all of them lie in the circumference, right? So that's why ABCD is a cyclic quadrilateral. All right, now if we know this angle, this full angle, that is DAB, then we know that angle DAB plus DCB. Okay, so since they are lying in the opposite one, so sum of them will be equals to 180 degree. All right, so that's what we are going to make use out here. So number two, in triangle ABD, that is ABD is this triangle. Now I am taking this triangle in order to find DAB. All right, so we know that sum of the angles will be 180 degree. Okay, so let us put the values. So we have ABD is 50 degree, right? BAD we don't know, and BDA is 33 degree. Okay, so from here we'll calculate what is BAD. So from here we see that BAD turns out to be 97 degree. All right, now in cyclic quadrilateral, BAD plus BCD or DCB will be equals to 180 degree, right? So let's put the value of BAD. So from here DCB turns out to be 83 degree. All right, so the value of DCB is equals to 83 degree. Okay, now the last part says find CAB. So CAB means this. All right, and we know the value of this full angle. From here to here we know, and from here to here also we know. That means this can be written as this bigger angle minus this 27 degree. All right, so we have angle BAD, this bigger angle is equals to 97 degree. Now this BAD can be written as BAC, that is this, plus CAD, right? Okay, now let us put the value of CAD, because we already know CAD, which is 27 degree. So from here we get BAC equals to 70 degree, that is BAC means CAB. So my value for angle CAB turns out to be 70 degree. So pause the video to note down. Okay, now let's see question number 17. So in the figure given below, AB and CD are straight lines. So AB and CD are straight lines through the center. Okay, so through the center O. Now it is given that AOC is 80 degree, right? So this is AOC is 80 degree, and CDE, that is CDE, is given to be 40 degree. Find the number of degrees, that is the angle DCE, that is DCE is this angle, right? And ABC, that is ABC is this angle. All right, so we need to calculate these two angles out here. Now, since it is clearly stated that AB and CD passes through the center, that means this CD is nothing but the diameter, right? So that's why we can say in the circle COD, that is this line is a diameter. Now whenever we see diameter, we know that the diameter divides the circle into two semicircles. Okay, so that means this side is also semicircle and this side is also semicircle, right? Now one more thing, we know that angle in a semicircle is always 90 degree. So in this semicircle, this angle is going to be exactly 90 degree. All right, so we have CED equals to 90 degree. Now in this triangle, we know this angle, we know this angle, then can't we find this angle? Definitely we can find this angle. All right, so we have in a right angle triangle, this is triangle CD. All right, so in triangle CDE, that is CD is this triangle. So we have, since this is 90 degree, then this plus this has to be exactly 90 degree. All right, so we have CDE, that is this angle is how much? This is 40 degree. That's what is given to us, right? CDE or EDC also we can call it, right? So this is given to 40 and we have to calculate DCE, right? That is this angle. So from here DCE turns out to be how much? 50 degree. All right, so we have found it, this one. Now our next aim is to find ABC. All right, now let us observe triangle OBC. Okay, now in this OBC triangle, OB is extended, okay, till A. Then this becomes your exterior angle, isn't it? Now we know that exterior angle will be equals to sum of the opposite interior angles. Now if this is my exterior, then the opposite interior angles are this one and this one, right? Okay, so that's why we have in triangle OBC, exterior COA, that is this will be equals to OBC, that is OBC, that is this, right? And plus OCB, isn't it? So we have COA equals to how much? It will be equals to 80, right? And OBC, that is this angle, we don't know, but we know OCB, that is this angle, and this angle is how much? It is 50 degree. So from here let us calculate what is OBC. So OBC turns out to be 80 minus 50, that is 30. That is this angle, sorry, this angle is OBC is 30 degree. That means OBC is also written as ABC, right? So that's why the value of angle ABC is 30 degrees. So pause the video to note down. Okay, so let's read out this particular question. So question says, in the figure, AC is the diameter of a circle. Okay, so AC is the diameter of a circle, that is this yellow colored circle, whose center is O. Okay, so O represents the center of this bigger circle. A circle is described on AO as diameter. Okay, so in keeping AO as diameter, we have drawn one more circle, that is green colored circle. All right, now AE is a chord of the larger circle. So AE is the chord of the larger circle, and this chord intersects the smaller circle at B. So AE is intersecting this smaller chord at B. All right, now we need to prove that AB is equals to BE. Is that clear? Okay, so before I do that, let us do some construction. That is, I am joining BO. All right, so construction says join OB. Okay, now here let us observe this smaller circle. Okay, now AO is the diameter, right? And the diameter divides a circle into two semicircles. That means in this semicircle we must have this angle to be 90 degree, isn't it? So we have angle ABO equals to 90 degree. Why? Because it is the angle in a semicircle. Now in other words, can I say this is 90 degree, right? This is 90 degree. So can I say this OB is perpendicular to AE? Yes. So we can say that OB is perpendicular to AE. Okay, so from your class 9 circles chapter, you came across a very important theorem which said that whenever you draw a perpendicular line from the center to a chord, then the chord gets bisected. So that's what you have learnt in your class 9 circles. Similarly, here also we have got a chord and you are drawing a perpendicular line from the center, right? Because we know that this is perpendicular, so you are drawing a perpendicular line from the center to a chord. That means whenever you are drawing a perpendicular, then the chord gets bisected. That means AB will be equals to BE. All right, so OB bisects chord AE. That means AB will be equals to BE. That is, this will be equals to this one. So we have proved this. So pause the video to note down. Okay, so let's see question number 19. So if in the following figure angle BAD is given to be 96 degree, so we need to calculate BCD. BCD, that is this angle, and BFE, that is this angle. All right, so let us calculate these two angles. Now let us see this first circle. In this first circle, we clearly see that A, B, C and D, all of them lie in the circumference. So that's why ABCD is a cyclic quadrilateral. Okay, so in cyclic quadrilateral, this angle plus this angle, that is angle BAD plus angle BCD. So this will be equals to 180 degree. All right, now let us put the value of angle BAD, so which is given to be how much? 96 degree. Okay, so from here BCD turns out to be 84 degree. So the value for angle BCD is 84 degree. Now the next thing that we need to find here is BFE, that is this angle. Now in the second circle also, B, F, E and C, all of them lie in the circumference of the circle. So that's why BFEC is also a cyclic quadrilateral. All right, now if I extend this CE, okay, so if I extend this CE, then this becomes your exterior angle, right? And one of the theorem of cyclic quadrilateral says that the exterior angle of a cyclic quadrilateral will be equals to interior opposite angle, isn't it? So that's why we say exterior BCD, that is BCD, this is the extended line, so this angle will be equals to opposite interior. So this is my opposite interior, right? This is exterior, this opposite interior, that is BFE. Okay, so this angle and this angle, they have to be equal. And what is BFE? BFE is 84 degree, right? So that's why we have angle BFE equals to 84 degree. All right, so we know that BCD, this angle is equals to 84, so that's why BFE also turns out to be 84 degree here. All right, now let us move on to the next case, that is AD is parallel to FE, that is this and this are parallel. So that's what we need to prove. All right, now in order to prove that, suppose let us assume these two are parallel, then this line AF acts like transversal, right? Okay, now in transversal, what happens is some of the angles in the same side of the transversal will be 180 degree. So that's what we have learned in our junior class, and we have already seen one other problem of this kind. Okay, so that means if this is your transversal, some of this angle and this angle has to be 180 degree. Now let us check whether we are getting 180 or not. All right, so BAD is 96, right? And another is this one, that is BFE. Okay, so BFE is 84. Now 96 plus 84 gives me 180, right? So that means this and this gets added to get 180 degree. So that's why we can say that the angles, okay, so these two angles are the angles of the same side of the transversal. Okay, so these are on the same side of the transversal, that is AF. All right, so that's why we see if this is my transversal, then AD and FE has to be parallel to each other. So pause the video to note down. Okay, so let's move on to the next question. So the diagram in your textbook is not given, only question is given. Okay, so question says, prove that the parallelogram inscribed in a circle is a rectangle. So parallelogram inscribed within a circle will be a rectangle, and the rhombus inscribed in a circle will be a square. Okay, so the next one is number 2. You will try by yourself. I'll just show you the first one. Number 2 is also going to be the same. All right, so let us see the first case. So there is a circle, okay, and I have drawn a parallelogram within the circle. All right, so these two are parallel here and these two are parallel here. Okay, so we have from 1 we see that ABCD is a parallelogram in circle with center O. All right, now can I call ABCD to be cyclic parallelogram? Yes, because A, B, C and D, all of them lie in the circumference, right? So that's why I can call ABCD to be a cyclic parallelogram. Now in a cyclic quadrilateral, we know that the sum of the opposite angles will be 180 degree. That is, angle A plus angle C will be 180 degree. Now one more thing that we know about parallelogram is the opposite angles will always be equal, because this is a parallelogram, right? So the opposite angles will always be equal. That means angle A and angle C both are equal to each other. All right, so can you see if this is also, if these two are equal, okay, so can I write angle A instead of angle C? Yes, so we have angle A plus angle A. So angle A plus angle A is 2 angle A. So 2 angle A is 180. So that means one angle A will be 180 by 2, that is 90 degree. Okay, so now since angle A is 90 degree, angle C will also be 90 degree because they are equal to each other. All right, so that's why angle A is equals to angle C and both of them are 90 degree. That is, this is also 90, this is also 90. Now similarly, we have sum of these two will be 180 degree, but since they are opposite angles of parallelogram, they will be equal. So that's why this also has to be 90 and this also has to be 90. So similarly, we can prove that angle B is equals to angle D and this is equals to 90 degree. All right, so that's why if all the angles, if the corner angles are 90 degree, then what does this mean? This means that this is nothing but a rectangle. Okay, so each angle of a parallelogram is a right angle. So this means ABCD is a rectangle. All right, so number 2 you will try by yourself. So pause the video to note down. Okay, let's have a look at the next question. So in this question, it is given that in the figure AB is equals to AC. So AB is equals to AC. So we need to prove that DECB is an isosceles trapezium. All right, so isosceles trapezium means, first and foremost, in a trapezium, two sides will be parallel. All right, and in an isosceles trapezium, what happens is the sides which are not parallel, they have to be equal because this is isosceles. Okay, so from this figure, since we need to prove that this is isosceles trapezium, we need to show here that DE and BC are parallel. So first thing is that one. Okay, and the next thing that we need to show is DB is equals to EC. Okay, so if DB is equals to EC, then only we see that the trapezium will be isosceles trapezium. All right, now let us begin. Now in the figure it is already given that in triangle ABC, this AB and AC is given to be equal. Now AB and AC are equal means that the triangle is isosceles, right? So this triangle ABC is an isosceles triangle. Now these two angles have to be equal because this is isosceles triangle, right? So that's why I am writing angle B is equals to angle C. All right, now DFCB is a cyclic quadrilateral because DECB, all of them lie in the circumference, so that's why DECB is a cyclic quadrilateral. All right, so in a cyclic quadrilateral, we know that the opposite angles, when they are added, you will get 180 degree. All right, so we have angle B plus DEC. Okay, so angle B and DEC is equals to 180 degree. Now angle B is equals to angle C, right? So instead of angle B, can I write angle C? Yes. So if I write angle C, we have angle C plus DEC equals to 180 degree. Now let us see where is angle C. So this is angle C and DEC is this one. All right. Now this one and this one, they are parallel. That's what we need to show, right? So if these two are parallel, then this EC acts like my transversal, right? So if this is my transversal, then sum of the angles on the same side of the transversal should be 180 degree. So that's what is happening here. That is angle C and DEC. They are adding up to 180 degree. All right. So this is acting like my transversal. So that means DE is parallel to BC. Okay, so this is the sum of the interior angles on one side of the triangle, one side of the transversal, that is these two, right? So that's why we have DE is parallel to BC. So one thing we have already shown. Okay, now we came across the conclusion that DECB is a trapezium. All right, now let us prove that DB is equals to EC. All right, so let us begin. Now we came across the fact that this and this both acts like transversal. All right, because this is DE and BC are parallel, so that's why this EC and DB has to be transversal. Okay, so it is said that ADE is this angle, so this angle is equals to angle B because they are corresponding angle, right? In a transversal we know what is corresponding angle. Now we have AED, so AED is this angle, AED, so this angle will be equals to angle C. This is also corresponding angle. All right, now in this smaller figure, in this smaller triangle, we see that this angle and this angle both are equal. That means this is also what? This is also isosceles triangle. That means in an isosceles triangle, AD will be equals to AE. All right, so we have, okay, so since angle B and angle C both are equal, so that's what we have seen. Okay, and angle B is how much? This one, AD, and this will be equals to AED. All right, because angle B is equals to angle C. Okay, so that means these two angles are equal. So that's why we can see that AD is equals to AE because they are opposite to equal angles. All right, so we have AB equals to AC, right? So AB is equals to AC. So that's what is given to us, right? So from here we have AB minus AD. See here carefully. So what I have done here is I have subtracted both sides AD. All right. So if I subtract AD out here, and if I subtract AD from AC, so instead of AD I am writing AE because we know that AD and AE both are equal. All right. So we have AB minus AD is how much? This one, right? So from here I have removed this part. So how much is left? DB is left, right? So we have DB out here in this side. Okay, and from AC I am subtracting AE. So from AC if I remove AE, then what is left? EC. So I am writing EC out here. All right, so DB and EC both are equal. Now I have written 1 here and I have written 2 here. So from this, from 1 and 2, we see that from 1 I can conclude that these two are parallel. So that's why this is a trapezium, right? And from the second case, these two are equal. So that means I can conclude that this is not only trapezium, but this is isosceles trapezium. So from 1 and 2, we see that DECB is an isosceles trapezium. So pause the video to note down.